once again, my fellow programmers. Welcome back once more to this drive course. And today we're going to analyze a couple of topics which are pretty simple. Before we move on to configuring in real time and show them to you. Okay? Remember guys that I'm going to be configuring our drives with the help of our 5-step methodology. So that way we are all able to see how real and impacting is this methodology, so that in the future you already have greater knowledge and more experience. So you'll see that this is very, very simple, this whole drive thing. So today's topic, we're going to be talking about the acceleration and deceleration times in our motor. In a different course that I imparted, it was a much more extensive topic compared to other specialty studies because we had to do mathematical calculations and a little bit more complex things and topics. Everything related to motion control, etc. So there are different types of profiles for motion. One of the most common ones is the trapezoid motion profile. Now, what is this about? We simply have to analyze our graph in two variables. One variable is speed, and the other one is time. So for motion, we need to know exactly our position. Which position? My servo motor position. So in this case, for drives, we need to know about precision, only for some applications. But what we're really interested in is knowing our speed, our velocity. So therefore, for both cases, we may be missing our variable for distance. Remember that velocity equals distance over time. And we generally don't need this, generally. However, we do have our variables, which are speed and time, in our motion part, at least. And for drives as well. So this graph is going to help us out a lot in understanding our acceleration and deceleration topic. When we have a constant speed, for example, let's suppose that our motor is going to be running at 1500 revolutions per minute, or 1500 RPMs. Now, these speeds that we generally get from our data plates in our motor, these are nominal speed, which means that these are established speeds once we start our motor. But what time is it going to take, or how much is it going to take our motor to get to that constant speed? That, guys, is acceleration. So acceleration is basically this incline, this time, the amount of time it takes to get to nominal speed. That's the average speed. Now, how long would it take to get that average speed? That time is going to be reduced or decreased, or elongated, or, depending on what we as engineers, as automation engineers, are configuring. Depending on what we're configuring in our drive. And on the contrary, once we find, and once we've already started our motor and we have an established speed, a set speed, what would happen if I pressed the stop button? Well, in this case, how long, and let's analyze this, how long would it take in going from nominal speed, which is our example, which is 1500 reps per minute, to 0. Okay? So going from 160 hertz frequency to how long will it take to be completely in 0 hertz? Whether it's 30, 40, 50 hertz, it's not the speed that we would be setting. So from that nominal speed, how long would it take for us to get a 0 speed? That is deceleration. So time, and this is what is indicated in our graph. So constant time and deceleration time. So here it doesn't really matter our nominal speed, but for how long is acceleration and deceleration, what are we interested in? These are the inclines that we are mostly interested in. The initial incline and the ending incline. The one that goes from 0 to nominal speed. And nominal speed to 0. So it's pretty simple, guys. Now, how are we going to move on to our drives? Let's see here. Let's analyze this. Here we go. So again, we have our faithful friend, our manual. This is always going to be our best friend and when we configure drives. Now, how are we looking for these parameters in case this is necessary? Remember, guys, that this is all within our drives monitor. These are other important parameters, however, not obligatory, unless the application asks for this. In case your boss, once they configure this and they say, you know what, sir, the engine is taking a little bit longer than we would expect to start. Now, why does this happen? Not to worry. Let me modify the deceleration or the acceleration speed. This is key to look for this. Now, here we have an optimal configuration. See, this is a pump application, which is going to go pretty quick. So in 1 second, it's going to take only 1 second to get to that speed, that nominal speed. And in deceleration, it's going to take from nominal speed to 0 speed in the deceleration time. So it's 1 second, basically. It's pretty quick. Now, as a drill, I would like you guys to enter the data or C101 parameter, and you tell me what deceleration time you have for your motor. Same thing goes for your deceleration, so that we can start getting used to our acceleration and deceleration. Now remember, guys, that this is time. We're not really messing with anything else. Now, that time is already predefined, but we can elongate, so we need to keep this in mind on what we can do within our drive. Okay? So this is pretty simple. Run this exercise and leave it in your comments or in the comments the acceleration and deceleration time. Whatever you got for your simulator. Okay? All we need to do is we need to look for this in parameters, and here we have our deceleration time. Now you guys tell me what time you have. Remember, guys, we are working with seconds. Okay? Now I'm not going to do this because then I'm going to give you all the answers. So let's take this, guys, and you guys do this by yourselves. Okay? Now let's move on to our next class. Thank you very much for your time, guys.